Hello guys, welcome to a new video with in lecture 10. It's about the piping flow in pipes part 2. Uh, Problem 1 says a 6 centimeter diameter horizontal water pipe expands gradually to a 9 centimeter diameter pipe. The walls of the expansion section are angled 10 degrees. This is a mistake. It should be theta equal to 20 degrees. Okay, so from the axis, the average velocity and the pressure of water before the expansion section are 7 meter per second and 150 kilopascal respectively. Determine the head loss in the expansion section and the pressure in the larger diameter pipe. So we assume that the flow is turbulent and alpha is equal to alpha is constant, which is equal to 1.06. So yeah, so now we can say that we need to go to the table because we have 20 degrees. So we go to the table here. So in this table we have that, as you can see, we have here at expansion for 20 degrees. Okay, so expansion for 20 degrees, d over d is equal to 0.2, d over d is equal to 0.4, d over d is equal to 0.6, as d over d is equal to 0.8 for KL, 0.1, 0.15, 0.25 and 0.30. So from that table, first we need to find now d over d. D over d is equal to the smaller one is 6, the bigger one is 9. This will give you 2 over 3, which will give you 0.666. So in this table, do we have 0.666? No, we have 0.6 and 0.8. And for 0.6 is 0.15 KL, and the 0.8 we have 0.1 KL. So now we need to do the interpolation because we need to find exactly 0.666 is equal to what KL. So it's very easy, very simple math. Now we will say that KL, and then we have the d over d. Then we have 0.15. This is all from the table. Then we have 0.666, but we don't know the KL for it, so I will just write KL, and then, or I can just call it KL2, for example, and then this is 0.1, this is 0.8. So we would say we would do 0.1 minus 0.15 divided by 0.1 minus KL2 equal to 0.8 minus 0.6 divided by 0.8 minus 0.666. What I basically did is I subtracted this from that and then this from that, and the same way on the other side I have to subtract the same in the same order. So after that, after simple math, I will get KL2, which is equal to 0.1335. So now we got the KL for d over d. Now we can carry on and we can use the Bernoulli's equation, P1 divided by rho over G plus alpha 1 V1 squared divided by 2G plus Z1 equal plus H pump U equal to P2 divided by rho G plus alpha 2 V2 square. By the way, we said alpha is constant, so alpha 1 and alpha 2 will equal to 1.06. So 2G plus Z2 plus H turbine E plus head loss. So what we don't have, or what I mean, in this equation, we know that they both enter from here and exit from here. So Z1 and Z2 are the same, are on the same level. There's no elevation between the Z1 and Z2. So we cancel them. What else do we have? We don't have pump. We don't have also turbine. Yeah, we have pressure. We have pressure. Okay, that's it. Now we continue. P1 over rho G plus alpha 1 V1 squared divided by 2G equal to P2 over rho G plus alpha 2 V2 squared divided by 2G plus the head loss. Okay, so from this equation, what we need to do is we need to get V1 and V2. We have V1 but we don't have V2. So first let me use another color, example this one. Okay, so we know that m dot 1 is equal to m dot 2. So rho V1 A1 is equal rho V2 A2. So rho times V1 by D1 square over 4 is equal rho V2 times by D square 2 over 4. So we will cancel the similar things. We have rho on both sides, we have 4 on both sides, we have by on both sides, but V1 times D1 square equal to V2 times D2 square. And we have, by the way, V1 is equal to 7 from here. V1 is equal to 7 meters per second. So from that we would say 7 times, what is D1? D1 is equal to 6 and 9 for D2. So 0.06 square equal to V2 times 0.09 square. So V2 will give you 3.11 meter per second. Now we found V2 and we already have V1, and we also have P1, which is equal to P1 equal 50 times 10 to the power 3 Pascal. So now let's continue from this equation. We continue here. So let's use another color. Example this blue. So let's say P1, which is 150 times 10 to the power 3 divided by rho, which is what is rho here? By gradually there was a, so I think we are using water, right? Yeah, so the rho will be 1000 or first let me rearrange the equation better. Let me rearrange the equation. So I would say, because I need P2, right? So P2 is P2 over P2 over rho G is equal to alpha 1 V1 squared divided by 2G plus P1 over rho G minus alpha 2 V2 square divided by 2G plus the head loss. Okay, so now I can say that P2 equal to rho G, because I took this one to the other side, multiplied by alpha 1 V1 squared divided by 2G plus P1 over rho G minus alpha 2 V2 square over 2G plus the head loss. So now I can take, I can make it more simple, but I will just substitute. So 1000 times 9.81, alpha is 1.06 times V1 square, which is 7, I guess. Yeah. So 7 square divided by 2 times 9.81 plus P1, which is 150,000 divided by 1000 times 9.81 minus 1.06 times 3.11 square divided by 2G, divided by 2 times 9.81 plus the head loss, but we don't have the head loss, so we will find it here. What is the head loss? Head loss is equal to KL times V1 square divided by 2G. So the head loss will equal to 0.1335. Yeah, guys, I forgot just to tell you. I already told you 0.1335. Okay, so this is the KL multiplied by V1, which is 7 square divided by 2 times 9.81. So the head loss is equal to it will give you the 0.00 0. 1.333 meter. So now we found the head loss. Now we can continue to put it, to substitute it here, 0.333. So yeah, just put it in your calculator. You will get P2 equal to 171.054 kilopascal. And we found the P2. So the pressure in the larger diameter pipe is equal to 171.054 kilopascal. I hope you enjoyed the video. I hope you learned from the video. Thank you for watching.